Hi everyone, this video is going to go through the 2011 FRQ number 6. So I'm just going to walk through the solutions here so you can check your work. All right, so what we're given here is a piecewise function f. The first part is asking us to show that f is continuous at x equals 0. So by definition, to show continuity, if I'm looking for showing it's continuous at x equals 0, I need to show that the limit as x approaches 0 from the left of f of x is equal to the limit as x approaches 0 from the right of f of x. So that would tell me that the limit exists. Then for continuity, we need to show that that limit is equal to the function value at 0. So we're just going to use our definition to figure this out. So if I want to know the limit as x approaches 0 from the left, I'm looking where x is less than or equal to 0, and I'm just going to substitute 0 for my function. So I would have 1 minus 2 times the sine of 0. Well, sine of 0 is just 0, so we get a value of 1. So from the limit as x approaches 0 from the right, again, if I'm showing this is continuous, I'm hoping it's 1. So 0 from the right is where x is bigger than 0. I'm going to substitute 0, so I get e to the negative 4 times 0, which just gives us e to the 0, which is 1. So far we know that the limit exists because the left hand and the right hand limits are equal. Now f of 0 is actually just the same as our left hand limit because that was where x is less than or equal to 0, and that value was 1. So now we can just say that f is continuous at x equals 0 since that limit as x approaches 0 is equal to f of 0, and those equal 1. So then we've shown that f is continuous. And just so you have an idea here, this was worth 2 points on this exam. And they just grouped that all together for the analysis here with 2 points. All right, so now for part B, it says for x not equal to 0, so we don't have to worry about x being 0, express f prime of x as a piecewise defined function. So that's our first job. So f prime of x, all we're going to do here is literally take the derivative of each piece of the function. So the derivative of 1 minus 2 sine x, derivative of 1 is just 0. I have negative 2 times the derivative of sine, which is just cosine x. So that's for x less than 0. Here I have e to the negative 4x, so we just have to watch out for the chain rule. It's going to be e to the negative 4x times the derivative of negative 4x, which is just negative 4. So we're going to get negative 4 e to the negative 4x, and that's for x greater than 0. So that's the first part, expressing f prime as a piecewise function. Now they want to know the value of x for which f prime of x is equal to 3. Well, for f prime of x, we have 2 pieces. So we could consider negative 2 cosine of x, where that's equal to negative 3, or negative 4 e to the negative 4x equal to negative 3. Now, the first part, hopefully we recognize this is not going to be equal to negative 3. Since cosine, right, the cosine of x, we know cosine has values between negative 1 and 1. So if cosine of x takes on values between negative 1 and 1, that whole function, negative 2 cosine x, is going to be between negative 2 and 2. So that's never going to be equal to negative 3. So now let's look at our other function here and let's solve this for x. So the first thing I'm going to do is divide by that negative 4. So I'm going to get e to the negative 4x. If I divide by a negative 4, a negative over a negative makes it positive. Now, hopefully you remember we did a lot of work with these functions when we were doing differentials. If I need to get negative 4x out here, I'm going to take the natural log of both sides. So now I've got the natural log of e to the negative 4x is just negative 4x equals natural log of 3/4. So then to get this by itself, I'm going to divide or multiply by the reciprocal. So I get negative 1/4 times the natural log of 3/4. All right, so for part B, they gave 2 points for writing that piecewise function for f prime. And then down here for getting the value of x, they gave 1 point. All right, that's it for this one. Reach out, please, if you have any questions or want to go through this in any further detail. Thanks.